Hi guys, I'm gonna explain equilibrium a little bit further over here. So just to make it more clear, okay, because I did one mistake, which was the first question. I explained it wrong, and so I just want to explain equilibrium in general. First thing, okay, what increases the rate? Increases rate of reaction. We have, in the case of solids, only the increasing of the surface area. In the case of liquids, okay, liquids is only in the increase of temperature, okay? However, aqueous solutions, we have concentration, okay, and the temperature. And finally, the gases, okay, what about the gases? We have concentration plus temperature plus pressure plus volume. So please, if you guys can screenshot this and keep this, it's very, very important. So what increases the rate of a reaction? The solids, its surface area. The liquids, it's the increase of temperature. The aqueous, it's concentration and the temperature. And for the gas, it's the concentration, temperature, pressure, and volume. Now, about equilibrium. Let me explain equilibrium in this term. Reactants, products, okay? If we are gonna do a change to the reactants, for example, okay, we are gonna increase the concentration. We need to follow 4 steps that I mentioned earlier, or that your teacher probably explained in class. The first one is the impose change step, okay? What do we do here? We see what is the imposed change. Our imposed change is to increase the concentration. The second step is to state Le Chatelier's principle. What is his principle? It's that if a system is reacted, or there is a change to this system and it's at equilibrium, okay, here we're doing a change by increasing the concentration and it's at equilibrium, okay, then Le Chatelier says that it will partially counteract. Okay, now that was step number 2. Step number 3 is to say how does it partially counteract. So this happens by, if it partially counteracts, this is what's gonna happen. It's gonna say, we're gonna take the reactants, or the place where we put the imposed change. I'm gonna do this one for reactants, okay? We put an imposed change in the reactants. Now, the partial counteraction will be what? We will go to the reactants and we'll do the opposite of our change. So the concentration, instead of increasing, will decrease, okay? Now, for the concentration to decrease, the reactants will have to give some of what it has, some of the concentration, to the products. So consequently, it will follow this arrow, which is a forward reaction. So this happens what? By decreasing the concentration of reactants. Okay? And now the fourth and final step is as a result. Okay? What happens as a result? As a result, the concentration of reactants decreased, but the concentration of products increased, and it's shifting forward. So shift is forward. How do we know if it's forward? If it's going from the reactants to the products, then it's forward. And then if it's going from the products to the reactants, then it is backwards. Another example I will give, we have reactant, and then we have product plus heat. If we have heat in the product side, then this is an exothermic reaction. Alright? Now, let us say, for example, our change is that we are gonna decrease the temperature. Okay? So we start step 1, impose change. It is what? Decreasing temperature of products. Alright? That was our impose change. Second step is Le Chatelier's principle, which is partial counteraction. Now for it to partially counteract, we will go to where we put the change. We put the change in the products. Okay, we're gonna go here. And we're gonna do the total opposite of what the change we said or we did. So if we're decreasing the temperature, a partial counteraction will be the total opposite, which is an increase in temperature. Okay, so how does this counteraction happen? We say this happens by increasing temperature of products. Alright, I need an extra page for this one. So now our fourth step is as a result. So if we are increasing the temperature, if we are increasing the temperature of the product, then we need to take in the heat from the reactants or from the opposite side. So if its temperature, for example, it was 100 degrees and then we increased it to 200. Where will we get this temperature from? From the opposite side. So from the reactants, we are going to be giving heat to the product so that it will increase. So now, what is this reaction? It is going from the reactants to the products, so it is a forward reaction. So as a result, the temperature of reactants decreases because we gave from the temperature of the reactants to the products. Then there is an increase in the temperature of products, and it is a forward shift. So I hope this helped explain equilibrium a bit more, and thank you guys for watching.